Hello and welcome to this GCSE Science Additional Chemistry revision video on electrolysis. In this video we will look at acids and alkalis, making salts, the electrolysis of brine, the electrolysis of aluminium and electroplating. Acids have a pH less than 7, bases have a pH more than 7. When a base is dissolved in water, they are known as alkalis. Salts are made when an acid reacts with a base, carbonate or metal. The name of the salt is formed depends on the metal in the base. For example, if hydrochloric acid is used, then the salts formed will be chlorides. There are a few key phrases that we need to know when talking about acids and alkalis. Acids are substances with pH less than 7. The stronger the acid, the lower the pH number. Acid turns blue litmus paper red. They turn universal indicator red if they are strong, or orange and yellow if they are weak. Bases. Substances that can react with acid and neutralize them to make a salt are called bases. They are usually metal oxides or metal hydroxides, for example, copper oxide or sodium hydroxide. Bases that dissolve in water are called alkalis. Copper oxide is not an alkali because it does not dissolve in water. Sodium hydroxide is an alkali because it does dissolve in water. Alkali substances have a pH more than 7. The stronger the alkali, the higher the pH number. Alkalis turn red litmus paper blue. They turn universal indicator dark blue or purple if they are strong, and green and blue if they are weak. Neutral solutions have a pH of 7. They do not change the colour of litmus paper but turn universal indicator green. For example, water is neutral. You need to be able to describe the reactions of acids with bases, carbonates and metals. You should be able to work out the particular salt formed in each reaction. If an acid reacts with a base, then a salt and water is made. This is called a neutralization reaction. The two general formulas for it are an acid plus a metal oxide will go and form salt plus water, or an acid plus a metal hydroxide goes and forms salt and water. When acids react with metals such as magnesium and zinc to make a salt, and hydrogen, its general formula is an acid plus a metal goes to form salt and hydrogen. The hydrogen causes bubbling during the reaction and can be detected using a lit splint. You usually see this reaction when looking at the reactivity series. When acids react with carbonates, such as calcium carbonate, a salt, water and carbon dioxide are made. Its general formula is acid plus a metal carbonate goes to form salt, water plus carbon dioxide. Notice that an extra product, carbon dioxide, is made. It causes bubbling during the reaction and can be detected using lime water. When atoms or group of atoms lose or gain electrons, charged particles called ions are formed. Ions can be either positively charged or negatively charged. You need to know which ions are produced by acid and which are produced by alkalis. You will also need to know the ionic equation for neutralization. When alkalis dissolve in water, they produce hydroxide ions. So for example, when sodium hydroxide dissolves in water, you form positive sodium ions and negatively charged hydroxide ions. When acids dissolve in water, they produce hydrogen ions. So, if you dissolve hydrogen chloride in water, you form positive hydrogen ions and negative chloride ions. Remember that an aqueous in brackets means that it is aqueous or in solution. When hydrogen ions react with hydroxide ions, from an alkali, a neutralization reaction occurs and water is formed. The general formula for it is H plus OH minus goes to form H2O. The salts made in neutralization reactions can be either soluble or insoluble. You can work out the name of the salt by looking at the name of the reactants. Nitric acid always produces a nitrate. Hydrochloric acid always produces a chloride. Sulfuric acid always produces a sulfate. Some examples of when the metal, so sodium reacts with hydrochloric acid, or sodium hydroxide reacts with hydrochloric acid to make sodium chloride plus water. Copper oxide would react with hydrochloric acid to make copper chloride, and so on. If you were using an alkali, which is a soluble base, then you need to just add enough acid to make a neutral solution. You can do this by warming the solution to evaporate it, and then you are left with large crystals. The most common form of this that might come up in the exam is when you talk about copper sulfate. Copper oxide and other transition metals or hydroxides do not dissolve in water. If the base is insoluble, then an extra step is needed to form the salt. You add the base to warm acid until no more will dissolve and you have no base left over. You can then filter the excess base off, which leaves the solution behind. The water that is in the solution can then either be boiled off or evaporated off, leaving your metal salt behind. Brine is a solution of sodium chloride and water. The process of electrolyzing brine involves using an electric current to bring about a chemical change to make new chemicals. The electrolysis of brine is a large-scale process used in the manufacture of chlorine from salt and two other useful chemicals. The two other useful chemicals are sodium hydroxide and hydrogen. The chlorine that we make by this process can be used in disinfectants, in plastics, and in the manufacture of hydrochloric acid. The sodium hydroxide that we make during this process can be used in purifying wood or manufacturing paper. The hydrogen that is made can be used as a potential pollutant-free fuel source. During electrolysis, chlorine gas forms at the anode and hydrogen gas forms at the cathode. Sodium and hydroxide ions are left behind in solution to form sodium hydroxide. A concentrated sodium chloride solution is pumped in at one end. When an electric charge is passed through it, it breaks down into its ions. Towards the positive ion, the electrode, the negative chlorine will move. When the negative chlorine goes and gets to the positive electrode, it will lose an electron and turn into chlorine gas. The positively charged hydrogen ions will move towards the negative electrode. When they get to the negative electrode, they will gain an electron and turn into hydrogen gas. Sodium hydroxide is left behind in solution, which can then be extracted. Aluminium is the most abundant metal on Earth. Despite this, it is expensive largely because of the amount of electricity used up in its extraction. Aluminium ore is called bauxite. The bauxite is purified to yield a white powder, which is just pure aluminium oxide from which the aluminium can be extracted. The extraction of aluminium is done by electrolysis, but first the aluminium oxide must be made molten so that electricity can pass through it. Aluminium oxide has a very high melting point, so would be expensive to melt. So, a compound called cryolite is added to it, which reduces the temperature needed to melt it. The diagram shows an aluminium oxide electrolysis tank. Both the negative electrode and the positive electrode are made from graphite, which is a form of carbon. The aluminium metal forms at the negative electrode and sinks to the bottom of the tank. Because the aluminium ions are positively charged, they move to the negative electrode and gain electrons. Oxygen forms at the positive electrodes. The oxygen reacts with the carbon of the positive electrodes, forming carbon dioxide, and they gradually burn away. Consequently, the positive electrodes have to be replaced frequently. When the oxygen ions move towards the positive electrodes, they lose 2 electrons when they form oxygen gas. During electrolysis, metal ions which are positive gain electrons from the negative electrode. The reaction for this, or the half equation for this, is aluminium 3 plus 3 electrons goes to form aluminium atoms. At the positive electrode, the non-metal ions, which are negative, lose electrons to form neutral atoms. These atoms join to each other to make molecules of oxygen gas. The half equation for this would be 2 O2 minus would go and form O2, which is oxygen gas, plus 4 electrons. Electrolysis is used to electroplate objects. This is useful for coating cheaper metals with more expensive metals such as copper and silver. It works simply by attaching the metal that you want to coat to the negative electrode, the metal that you want to coat it with to the positive electrode, and putting it into a solution of the metal solution such as silver nitrate or copper sulfate. In coating stuff with silver, the positive silver ions move through the silver nitrate solution towards the negative cathode, which is connected to what you want to coat. The positively charged silver ions form silver atoms, gain an electron, so therefore coat whatever's there. Remember, when revising, start earlier rather than later, keep questioning yourself, and quality revision is better than quantity. Good luck with your chemistry exams.